Good morning. Today we are going to start AC voltage controller. As of now, we have seen AC-DC rectifier. We have seen DC-DC converter. We have seen various characteristic of devices like thyristor characteristic, IGBT characteristic, MOSFET characteristic. All those things we have already seen, and today we are going to conduct lecture number 19, which is AC voltage controller. Isn't it? So this AC voltage controller are used to get variable AC from fixed AC source. We have two quantity which can be varied in AC, like we have voltage, we have frequency. We can vary either of these two पैरामीटर, अर्थात हमारे पास वोल्टेज और फ्रीक्वेंसी में से कोई एक को हम वेरी करके वेरिएबल फ्रीक्वेंसी प्राप्त कर सकते हैं. मैं हिंदी में इसलिए बोल रहा हूँ, कुछ छात्र छात्राओं ने मुझे बताया कि साहब इंग्लिश में बोलते थोड़ी सी दिक्कत होती है, तो मैं कोशिश करूंगा बीच बीच में हिंदी में भी आपको बताता रहूं. पर्पस ये नहीं है कि किस भाषा में बताया जाए, पर्पस ये है कि जिस भाषा में भी बताया जाए वो छात्र छात्राओं को समझ में आ जाए. क्लियर? सो अदरवाइज यू कैन डू, सी आप उसमें गूगल ट्रांसलेशन भी लगा सकते हैं, तो वो आपको यूट्यूब में चलते चलते हिंदी में भी बताता रहेगा, लिख क्लिक करके बताता रहेगा, वो काम आप कर सकते हैं. क्लियर? सो बच्चा पार्टी क्या है, हम वोल्टेज या तो वोल्टेज को बदल दें या फिर हम लोग फ्रीक्वेंसी को बदल दें. तो दो तरीके के सर्किट हमारे पास हैं. एक है एसी वोल्टेज कंट्रोलर. ये वो सर्किट होते हैं, दीज आर दो सर्किट विच कैन चेंज द फिक्स्ड एसी वोल्टेज इनटू वेरिएबल एसी वोल्टेज विदाउट चेंजिंग द फ्रीक्वेंसी. अर्थात फ्रीक्वेंसी नहीं बदलेगी, खाली वोल्टेज ही बदलेगा. वो कहलाता है एसी वोल्टेज कंट्रोलर. आगे हम लोग पढ़ेंगे साइक्लो कन्वर्टर, जो कि वोल्टेज लेवल तो फिक्स रखता है बट फ्रीक्वेंसी को चेंज कर देता है. तो अभी के लिए एसी वोल्टेज कंट्रोलर के लिए जो हमारा सर्किट है, सर्किट जो है वो ये चार तरीके के हो सकते हैं. आप देख सकते हैं, लेट मी ओपन दिस. आप देख सकते हैं, फॉर एग्जाम्पल हमारे पास एक सर्किट इस तरीके का है. तो जब जब ये पॉजिटिव होगा, जब जब ये पॉजिटिव होगा, लेट मी टेक द हाइलाइटर, जब जब ये पॉजिटिव होगा, इट विल कंडक्ट लाइक दिस. डायोड से होते हुए वी ट्रिगर थायरिस्टर एट एन एंगल अल्फा, सो इट विल गो थ्रू द डायोड एंड कम बैक हियर. तो दिस इज वन पॉसिबिलिटी. जब कभी ये सिरा पॉजिटिव मीन्स ये पॉजिटिव होगा, यानी नेगेटिव हाफ साइकिल में, तब क्या होगा, डायोड D3 से थ्रू डायोड D3 देन T देन D4 बैक टू सप्लाई. अर्थात जो सर्किट बनेगा वो हमारा इस तरीके से कंप्लीट हो जाएगा. इस समय करंट हमारी सप्लाई में वापस जा रही होगी, तो पॉजिटिव और नेगेटिव हाफ साइकिल हमको मिल जाएंगी. बट इसमें क्या होगा, व्हाट वुड बी द प्रॉब्लम, दिस थायरिस्टर विल कंडक्ट इन ऑल द टाइम, that means positive cycle as well as negative cycle, right? So it will get heated, it will get heated. अदर पॉसिबिलिटी क्या है, आप ट्राइएक का यूज कर सकते हैं. ट्राइएक इज टू थायरिस्टर कनेक्टेड एंटी पैरेलल, तो यू कैन हैव दिस सर्किट. और जब भी कभी आप मार्केट में जाते हैं तो एक बताता है कि साहब एसी रेगुलेटर, एसी रेगुलेटर, वेयर वी यूज दिस एसी रेगुलेटर, these AC regulators are used to control our fan or our induction motor in industry, right? Or it could be used for variable to get the variable temperature, right? In fact, there we use integral cycle control, that we will also see. This type of control is used whenever we want the variable voltage, where very variable voltage is required to control the speed of induction motor, or to get at the different value of temperature in the heater, so you apply variable voltage. So there we can use. तो आपने छोटे छोटे से वो रेगुलेटर देखे होंगे जो आपके पंखे को कंट्रोल करने के लिए आपके घरों में लगे रहते हैं। तो उसमें एक तो देता है साहब एंकर का लीजिए, हैवेल्स का लीजिए, वो देता है बहुत कॉस्टली, 150 रुपए 200 रुपए। वेयर एज इफ यू आस्क सम लोकल मेड, they are available at 50 rupees 60 rupees. Why is it so? Because they are half control. AC regulator means they controlling only on the half cycle. It is uncontrolled, I'll show you the waveform. It is uncontrolled, right? You can control only in the positive cycle, so 50% voltage you can control. But this type of control inject the DC current in the supply system, so it is undesirable. In fact, the load voltage is also some sort of DC is there, because there is no longer these two waveform, positive as well as negative, is identical, right? So the best controller which we use, that is this. Here you can have two thyristor connected anti-parallel. One is T1, other one is T2. One is T1. Let me change this color. It is T1, and other one is T2. Right? So it is like this. Now, if you see, we have triggered the device at an angle alpha. We trigger the device at an angle alpha. The moment we trigger, we get the positive supply of the voltage as it is, isn't it? And we trigger this T2 at an angle alpha, so we get the positive supply of voltage as it is, and the value of current is Vm by R. So you will get this waveform, these are the current waveform. T1 can be triggered during the positive cycle of the voltage. T2 can be triggered during the negative cycle of the voltage. I hope this is clear to all of you. We have already did so many things in the AC/DC rectifier. If it is not clear, you just check there. Here the circuit is only different, that T2 is triggered during the negative half of the cycle. So you will get like this. Clear? And just for simplicity, we have considered the resistive load. We will also see the RL type load and how the waveform is varying. Clear? So we understood that this type of circuit is not being used because that is not identical. We use this circuit. So this is the AC voltage controller. Now just see the various waveform for this AC voltage controller. This is the AC voltage controller you applied across the load. I have taken the resistive load just for simplicity. Now what happened? You trigger this T1 at an angle alpha. Let me make this red one. So you trigger this at an angle alpha, and this T2 is you trigger this T2 at an angle alpha, and it is in negative cycle. So T2 is like this. I have also shown the firing pulses, gating pulses in the same color in which I have drawn the thyristor. Clear? So it is like this. Let me make this also black. Okay, fine. So the moment you trigger, the output voltage start immediately coming at the output. The same input voltage will appearing at the output. During negative cycle, the voltage is negative, so this will appear at the output. Now, if we talk about the source current is same as the load current, whether it is flowing in this direction or it is flowing in this direction. So source current is same as the load current. Whatever the value of load current, that is the same as the source current, and it is the maximum value is given by Vm by R if this value is Dm, right? All these things are very, very simple. Now, if we talk about the thyristor voltage, whenever T1 conduct, the output volt, the voltage across this device is order of 1 to 2 volt. So during this period T1 conducting, so it is, you can see, let me zoom it. It is order of 1 to 2 volt, very small voltage, very small voltage, this much voltage, this much voltage, right? This is coming. Now once T1 is off, T2 is also off. So the voltage which was appearing is anode minus cathode, and this time after pi negative supply is coming, so this voltage, negative supply voltage, anode minus cathode, would come. Now once T2 start, T2 start means the voltage drop from anode to cathode is order of order of 1 to 2 volt when this T2 start conducting, right? It is order of 1 to 2 volt. So across this how much voltage would develop? It is negative of this, means minus 1 to 2 volt whenever T2 is conducting. Then again none of the device is conducting and positive cycle is going on, so positive voltage is coming. So this is the voltage across the thyristor T1. If someone asks what should be the voltage across the thyristor 2, it is reverse of this, because these are anti-parallel. Otherwise you can calculate the simple formula, means whenever any thyristor is conducting, the voltage across anode to cathode is order of 1 to 2 volt. When it is not conducting, whatever the voltage is applied across anode to cathode, that will appear, right? This is very simple concept, right? So this is the sorry, this is the waveform of thyristor across the thyristor. If you look at the circuit turn off time, the circuit is conducting, I mean it is in the circuit turn off time must be equal to during the time in which it is in reverse bias. So you can see the circuit turn off time is pi, omega t is equal to pi. During this time your circuit must be turned off. So time is equal to pi by omega. Omega is equal to 2 pi f. If supply frequency is 50, then this is 100 pi. Now let us do the harmonic analysis of this output voltage, as this is no longer the sinusoidal supply, but of course we can write in the form of sine and cosine, right? And neither V0 nor I0 nor the source current, any any quantity out of these three is sinusoidal, but we can write in the form of Fourier series. This you have already known, very simple mathematics is involved, but just for reference I am taking this in the lecture. Let us see this. The output voltage is given by summation of n equal to 1, 3, 5 to infinity an sin n omega t plus bn cos n omega t. Why only odd harmonics considered? Because the waveforms are symmetric and identical, so all even harmonic get cancel out. 2, 4, 6, 8 all get cancelled, and only odd harmonic will be appearing at the output. So, and the value of an is given by these are the quarter wave symmetry, and the waveform is given by 2 by pi 0 to pi v0 sin n omega t. Similarly, Bn is equal to 2 by pi 0 to pi v0 omega t cos n omega t d omega t, right? Where v0 is equal to how much? It is equal to Vm sin omega t. This is equal to Vm sin omega t. You can see these waveforms are symmetrical in nature. Positive cycle is symmetric, identical as the negative cycle. So all even harmonic get cancelled out, only odd harmonic would appear, and it is come out to be like this. Now just integrate this. For alpha to pi, it is equal to Vm sin omega t. So integration limit is changed from alpha to pi rather than 0 to pi, because from 0 to alpha it is 0. It has come out to be 2 Vm upon pi alpha to pi sin omega t into sin n omega t. Just expand this and you will get the an value is come out to be Vm by pi sin n plus 1 alpha upon n plus 1 minus sin n minus 1 alpha upon n minus 1. Give the name this equation as equation 3. Similarly, you have calculated this Bn. It has come out to be cos n plus 1 alpha minus 1 upon n plus 1 and cos n minus 1 alpha minus 1 upon n minus 1. If you will try to calculate the value of a1 b1, or before going to that, just see this Vm is equal to under root 2 times Vrms, where Rms is the supply voltage, right? And to calculate this an and bn, we must know that cos n plus 1 pi or cos n minus 1 pi, whether it is plus or minus pi, it is always equal to 1. So it will be used to get the value of this when you put this. So this is these terms get cancelled out and the final answer is come out to be like this. And you know the maximum amplitude of any nth harmonic can be calculated as under root of an square plus bn square, an square plus bn square, and the phase of that particular harmonic is tan inverse bn by an. Likewise, if you are interested to know the nth harmonic current, it will be given by Vnm by R, where Vnm is the maximum amplitude of the nth harmonic. So you know the A1, B1 means if you know An and Bn, you just put the value of n equal to 1. Can we calculate the value of A1, B1 using this formula? No. The reason is this quantity is undefined, because n minus 1 it is come out to be 0 by 0 form. It is come out to be 0 by 0 form. This n minus 1, this is cos 0 is 1, 1 minus 1 0, so 0 by 0 form. So it is undetermined. So how we can calculate A1, B1? We will simply put here the value of n equal to 1. So it is equal to sin omega t. Vm sin omega t into sin omega t. It has come out to be Vm times sin square omega t, and now we will calculate. The value of A1 is come out to be Vm upon pi sin 2 alpha by 2 plus pi minus alpha. Similarly, B1 is come out to be Vm upon pi cos 2 alpha minus 1 by 2. Now we will find out the value of fundamental component, maximum value of fundamental component, that is come out to be A1 square plus B1 square. And it could be solved as 2 cos square alpha minus 1. So after solving this, we get the no need to apply this 2 cos square alpha minus 1b. It is not giving something new. So let it as it is. Just see this is V1 is come out to be sin 2 alpha by 2 plus pi minus alpha square plus cos 2 alpha minus 1 whole square, and the entire thing is in under root. Entire thing is in under root. Similarly, fundamental phase difference we can find out. It is given by tan inverse B1 upon A1. So it is come out to be like this. This is for resistive load, but they see not for resistive load. This harmonics, these harmonics like third, fifth, seventh, all those harmonics. If you run the induction motor using this supply, the useful torque component is given by only the fundamental component, not the harmonics component. They simply create the problem of clogging, crawling, or the heating because of this voltage harmonics voltage. That so there it is not useful. But if you talk about the resistive load, in that case, all these third, fifth, seventh, each and every harmonic is used to produce the heating. So in that case, we know the RMS of output voltage. What should be the RMS value of that output voltage, AC regulator output voltage? Let us calculate this. It is given by 1 by pi, that is the period, alpha 2 pi V0 square d omega t, and V0 is equal to Vm sin omega t. When you solve this, you will get, it is come out to be Vm under root of pi minus alpha minus sin 2 alpha by 2, and limit is alpha 2 pi divided by 2 pi. Just write the value of Vm, it is come out to be Vrms times under root 2, and this 2 is get cancelled by this root 2. So it has come out to be Vrms 1 upon pi times pi minus alpha plus sin 2 alpha by 2. This pi is the get cancel out. This pi is get cancel out because the value of sin 2 pi is 0. Right? So the formula is come out to be like this. This is the VO RMS output voltage. RMS is come out to be this. Output voltage RMS is come out to be this. Let me put in box because this we will use in solving numericals. Huh? And simply the RMS current, it is simply the VO RMS by R. Now, if we want to know the power delivered by this AC regulator, it is simply IORMS square times R, or we could write it VORMS square by R. Here it is the output voltage RMS, not the supply RMS. This is different. This is different. This is here, and multiplied by this factor, it will give you the VORMS. Mind it. So we just put this. It is come out to be VORMS square upon pi R, pi minus alpha plus this. The maximum, when we, what is the maximum value of this? The maximum value of this is given by this factor is equal to 1. Right? P maximum is, means you trigger at an angle 0. You trigger the device at an angle 0. The moment this alpha is 0, that means sin 2 alpha is 0. It is come out to be pi. Pi get cancel out. The entire supply RMS square divided by R. This is the value of P maximum. So normalized value of output power, that is P divided by P max, is come out to be pi minus alpha plus half sin 2 alpha. Right? Now we talk about the input power factor. This input power factor is active power output. We have already derived this in when we were studying the AC/DC rectifier. बच्चों ये बात थोड़ा सा ध्यान से समझने की है कि चाहे आप AC/DC रेक्टिफायर पढ़ो, चाहे आप AC रेगुलेटर, पॉजिटिव साइकिल दोनों में ही सेम है. तो सेम थिंग इज एप्लीकेबल हियर एज वेल. राइट? लेट अस सी. Active power output divided by RMS power input. It is equal to VORMS square divided by VRMS times IRMS. So it is come out to be VORMS divided by VRMS. This is come out to be 1 upon pi minus alpha plus sin 2 alpha by 2. Right? Clear? Now if we put alpha equal to 0, input power factor, if we want to check the input power factor, let us put alpha equal to 0. So this factor is 0. When alpha is 0, this pi get cancel out. It is come out to be unity. And we know for resistive load, if you trigger the device at an angle alpha, and which is equal to 0, that means you are simply apply the entire supply to the resistive load, and the power factor would be unity. And here it is coming to unity when you put the value of alpha equal to 0. So our formula is justified. So with this, I'll end this lecture number 19 in coming lecture we will see the this AC voltage regulator with RL load, and we will also see the integral cycle control of this AC voltage regulator. So keep on watching on YouTube. I have already shared my WhatsApp number. If you have any doubt, you can WhatsApp me, or you can comment on this channel. Just subscribe the channel and press the bell icon so that whenever I come in the live, you can get the notification. Bye bye. Take care. Love you all. Keep on studying.